Okay. All right. Welcome everybody to the next session about building an infrastructure stack for AI-ready IT OT. I will admit to a little clickbaity wording in here, but you'll see that we're going to cover many bases towards this in this presentation. So it's a presentation based on our experience over the last couple of years on topics that are close to mine and my co-presenters' hearts. And what I hope you will hear is actually two complementary angles on a single topic. And that's how to design your infrastructure appropriately for the type of flexibility that we think is important now, and certainly to open up for the practical applications of AI in OT-style environments. And so the vendor perspective is from me. I'm Carl Moberg. I'm with Avasa. We build platforms for these types of environments. So I get to speak to a lot of users around it, but I don't have any particular stake in the actual manufacturing process. And I'm happy to join by Micael Baudin. He is an expert digital transformation at Sandvik Group. And the way I learned that is that he brings his perspective from someone who's working on prototypes and experimentation that he then brings to the larger Sandvik Group. So a good person to talk about when you talk about trying things out, prototyping, and trying to make things work, and then trying to get the organization to consume that from you. So we will go a little bit from an observation that I'm making at the heart of what we do and the kind of conversations we're having. We will then transfer to Micael, who will help me contextualize this whole thing from his own work in the Sandvik Group. So be prepared for some real world from him, while this is more of a builder perspective. And I will then bring us back and conclude the whole thing. And we shall work very hard to be on time. And we shall help each other to be on time. Okay. So let's get going. Oh, does this work, or do I poke some? Okay. Yeah. Okay, cool. All right. So my first slide is how I perceive, arguably a little bit from an IT perspective, how I perceive the system architecture for, let's call it the lower layer, the sensor level environment in the type of OT environments that we come across again and again. And what I'm trying to illustrate here is that most of what I would call the applications, meaning the coherent pieces of software, are stuck on hardware and then stuck onto operational dashboards. It's literally stovepipes all the way from the sensors up into the centralized environments. And this is kind of the environment where we as a vendor that we walked into. And there's a couple of really interesting challenges here. Most of them has to do with flexibility and the ability to actually pick and choose your own components and pick and choose your own future. And what we can clearly see over the last couple of years, while talking to manufacturers, is that things are converging in a direction that I've chosen to illustrate like this. The big difference here, of course, is that we've teased apart the application layer from the sensor and the compute layer, and we've made it into a coherent operative environment. Of course, what we believe is important with this thing, or this way of actually architecting the environment, is that you get full flexibility of choosing each layer. You get the full flexibility of actually switching out layers, and you get a coherent view across the application domains for the lower layers of this kind of architecture or infrastructure. And trying to kind of move this towards a setup for Micael to talk about the real world is that this is how we actually start to think about how our customers are moving towards this kind of environment. We love to talk about purpose-built or best-of-breed infrastructure stacks, starting, of course, from the sensor layer into the industrial PCs and connectors onto what we would call an edge application platform. And I promise you we will contextualize this with Micael's example. But an environment where applications can run close to the PCs, connectors, and the sensors in a manner that can be managed. And we suggest talking about two types of integrations. One is already in place. All of you that are actually manufacturers are already doing data integration. But an interesting angle that comes out of this rethinking of the architecture is that you need operations integration as well, because there's some new life cycles coming alive here in terms of the sensors, in terms of the hardware, and certainly in terms of the applications. I love putting 3 dots between the app boxes and AI, because we know that there's a lot of jittery nervousness, let's say, between the well-known, well-understood applications and the potential promise, the exploratory promise of deploying AI-based applications close to the sensors. And this requires a fairly strong operations integration on top of your already existing data integration. So let me take a step back and see if, Micael, you can actually make this come alive in your setting.
Hopefully. Thank you. Okay. Let's start by looking at the technical architecture that you see in this picture. It helps us to address the challenges to actually handle data at the far edge. So in the lower part of this picture, you can see the enterprise tier, as we call it, the pink swim lane. It contains systems, traditional systems like ERP, EOM, MES. They typically handle transactional data that have an update frequency of minutes, hours, and days. Going from left to right in this picture, it's showing the necessary building blocks to actually get the raw data into the hands of key stakeholders. But for the far edge data that I mentioned previously, a completely different solution is necessary. Mostly because we need to handle high-frequency data that is often connected to this type of data sources. So we still have the same columns and the same type of building blocks. Once again, defining which functions is needed to get the raw data into the hands of the key stakeholders. But the exact solutions we select for each building block will be very different in the blue swim lane compared to the pink swim lane. And that is because we need to handle the specific needs of the OT domain. And that is mainly connected to the variety of legacy equipment that we encounter there. While most of the time, the data that comes from in the pink swim lane is connected to some kind of cloud solution. Often the building blocks in the upper blue swim lane actually originates from far edge data equipment, manufacturing and supporting equipment, for example. Okay, the upper blue swim lane, we call it the edge or IIoT platform tier. It's in the lower pink swim lane that we usually find initiatives connected to digital transformation, often very mature. And in the upper blue swim lane, we find initiatives connected to Industry 4.0 implementations. Often less mature, but that's a good thing. Makes it, you can make a big difference, basically. Okay, let's move on then to... Okay, I missed that one. That was the second change. Okay, you might ask yourself, okay, what is so specific about the blue swim lane then? It might be more clear if you ask yourself this question. Where do these data sources reside? And then I mean topologically in the asset hierarchy in the company. Well, most often these are manufacturing, like I mentioned, manufacturing equipment, supporting equipment, which in turn means that it's going to be PLCs in these equipments or HMI computers close to the manufacturing equipment or applications at those HMI computers. And that means if you look at it topologically, it's going to look something like this. So to be able to actually reach down to the lower layer here to actually get data or deploy applications, you need to be able to actually handle a complex network landscape, basically. So, for example, we need to be able to pass through a firewall to actually be able to reach down to a production network. We might have to pass another firewall to get into some local area network. We might be able to actually pass another firewall to get into the HMI computer. So it's a rather complex landscape we have to deal with here. Okay, I'd like to sum up my part by presenting a few challenges that I think it's good to think about connected to this. Perhaps the most common one, and difficult one also perhaps, is the IT-OT convergence concept. And it's often very difficult to actually draw a line where OT and IT is, both in terms of equipment, but also organizational-wise, of course. We also have another gap that we need to consider, and that is the domain knowledge that exists in the leftmost part of the picture, the people actually doing the process at that stage, and the people working with the data. So these are the two gaps that we need to close to be able to actually handle this in a good way and future-proof it. The next thing I would like to bring up, once again, is this ecosystem, this complex network ecosystem, often actually also dynamic in the sense that it changes all the time. Cybersecurity is becoming more important for every day, so you might end up in a situation where you actually see that equipments are changing in your environment. Firewalls might be rented or switches might be changed. So you need to be able to handle that and be prepared for that also, this dynamic landscape, not only complex. The third part is, once again, something that I mentioned previously. It's this concept of legacy equipment. Legacy in the sense that compute at the far edge in the leftmost part of the picture must not be updated under any circumstances. That's usually the rule of thumb, which makes it difficult, but also a legacy mindset in many times. So most people are quite content where they are. They might not be that prone to change. So it's difficult actually to handle that mindset also. And that is another thing that is connected to the concept of data literacy. I think it's important to work with that in parallel also, to increase the level of data literacy within the companies where you're trying to do these things. Finally, we have this technical architecture I showed you in the beginning. These building blocks are functions, they are defining functions, but not really the exact solution that we put there. So we constantly need to reevaluate this, because the solution we selected yesterday, we might have a better solution today, or an even better solution tomorrow. That's how fast it goes. So we need to constantly reevaluate exactly which solution we select in this technical architecture to succeed. With that, I think I hand over to you to wrap up. I think we are on time.
We are on time, for sure. Thank you for that. Thank you for sharing your experiences with your environment. So maybe to conclude a little bit, here's what we think you should take into considerations, again, on kind of all levels, to set the playing field, if you like, so to level the field for the types of applications that we know that current generation production systems need, and certainly data-centric future or soon-to-be AI environments, right? The first one, and I can't push this enough, is to try and understand the concept of a best-of-breed stack. I know there's a lot of history with buying entire solutions from single or few vendors, but the type of challenges that we see over and over again kind of calls for taking on a little bit of the integration that generally has been kind of handed over to the vendors and bring that into your own culture to get out of maybe the legacy mindset that Micael mentions. Yep. That will eventually speed up and increase the agility and allow for a much larger playing field with testing different technical ways of satisfying, like you said, the feature blocks in the architecture. And there is a duality, and I think you covered it really well here, between the digital transformation reshaping the industry and kind of the pressure from cyber-physical security and all other kinds of things. So I'm not saying this comes for free, but I'm saying not doing it will actually be in the way for developing the types of applications and deploying the types of application that we believe certainly are key for the future of manufacturing. And it is truly moving from, let's call it, maybe a hardware-dominated environment into something that's more application and data-centric, arguably the other way around, maybe data-centric and then application-centric, with applications more of a supporting layer than the data layer. But if and when that gets right, or when you get it right, we see user after user being able to normalize and apply basic AI to the sensor data that they collect and overcome several, if not all, of the challenges that Micael laid out, ranging from mindset conversations all the way to network segmentation and the inability to reach sensor data that should be available, of course, to the environment and to the facilities where they are produced. So with that in mind, I think we can conclude and say thank you and open up for any questions that you may have. Wow. And any applause that you may have.
That's fine also.
Yeah. Any shouted questions? Otherwise, we will hang out to the side for a while. Particularly Micael, with his long experience, is probably a good source of information for you guys.
You're welcome.
All right, thank you.
Thank you.